So in this video, we'll look into OSPF areas. So OSPF can be divided into subdomains called areas. Area is a logical collection of OSPF networks, routers, links that have same area identification. So larger OSPF network, they suffer with single area design. What that means is you'll have a larger number of LSTB, and when that SPF algorithm has to run that we covered in our last video, it will take more time. Thus, the conversions speed time gonna be longer, and it's gonna saturate RAM and everything. So since the SPF has to run against the LSTB, so the larger it is, the longer it's gonna take, right? I mean, it's simple as that. So that is the reason we introduce areas. So each different routers, they can be into different areas, and thus they're gonna have a smaller number of databases. So the goal here is to reduce the size of the database for each router. Solution is take one large LSTB and break into several smaller LSTB by using OSPF areas. So that way, so a router within an area, it only maintains the database for that area which it belongs. If it is a router on area number 1, it only cares about the LSAs for area number 1, and outside this area, they don't care. So that's why you will have smaller LSTB, the SPF gonna be faster, things gonna look better. So decrease the convergence time. That's the number one feature we're gonna get. There are several others. So it's gonna, so every time your link flaps, bounces, the SPF has to rerun. So this is gonna optimize the OSPF network. So each OSPF area that is divided into area must follow these rules. So there are 3 rules that has to be followed. Number 1, the backbone area must exist. This is a must. A backbone area needs to exist. And if you have multiple of areas like area number 1, area number 2, so that's how you can define different areas. You need to name your backbone area 0. So that is a hard rule. Number 2, each non-backbone area must be directly connected to the backbone area. So this is necessary if you need an inter-area communication. So if you have multiple of areas, area 1, area 2, area 3, so on, and if area 2 routers needs to communicate to routers on area 1, it's not going to be able to do directly. So both of these areas has to have a link to area 0. So they have to first talk to area 0 and then to a different area, and same process in reverse. So that is essential. And when I say it must be directly connected, I don't mean physically directly connected. This is where the ABR gets introduced, the area border router, virtual links. So those are the way we accomplish this. Number 3, the backbone area must not be partitioned. So it's not be subdivided into smaller areas. That's going to cause a routing issue. So these 3 rules needs to be taken into consideration when you start implementing areas. And the question kind of comes, so when do we introduce areas, right? So what is our number that we need to start looking into areas? Unfortunately or fortunately, there is no hard number for that one. I mean, these all depends on like type of iOS you use, like what is your RAM, what is your CPU, what are the models and everything. So it's going to be different for every area. How big is your network, those kind of stuff. But I mean, there are some Cisco documentation they have suggested if you have maybe around like 50 routers in an area, you need to look into subdividing into a multiple area just to have a smaller LSTB. So that is kind of a guideline that can be taken into consideration. So area can be typed as just simply like integers, right? Area 1, area 2, area 3, and so on. Or it can be introduced as IP address as well. So it means the same. If you see area 0000, that basically means it's area 0. So either or decimal format or IP address format, either or is fine. So let's take a look more. So these are a few of the terms that we need to be familiar with. So it's an ABR. This is area border router. So this is a router with interfaces in two or more areas. So this is something we'll be using to connect area to a backbone area. So ABR will have one of its link to a backbone area, which is area 0, and other interfaces in different areas. So this will act as a proxy. ASBR, Autonomous System Boundary Router. So these advertises external destinations. So these are like external routes. Basically what they are the routes. Those are redistributed into OSPF from other protocols. So those are external routes. So that is the goal of ASBR. Backbone router. So this is a router connected to a backbone area, including ABR, area border router. Internal router, a router in one area except the backbone, right? Because if it is on the backbone, it's going to be a backbone router. So that is it on this series of OSPF foundation topic. If you have any confusion, just go back into the video. Just start from video number 1. All video builds into each other. So it kind of acts as a prereq. This will give you a good solid foundation of how OSPF works, how neighborships are created, what does link state protocol means, how are all those LSAs, LSTVs are shared, created, and how the Dijkstra SPF, the shortest path first algorithm works. So once you have a clear picture of the foundation topic here, you're going to be able to visualize, calculate your own path and everything. And if you see there is some issue, you'll be able to catch on much faster. So I really hope this video was helpful to you. You had some, you learned something. There was some value to this, to your knowledge, and I'd like to thank you for watching.